Hi, Serena Saiped. How are you doing?
Good and you, sir.
Oh, I'm good, thanks. I thought you guys are still enjoying maybe the holiday. I thought you're already on the holiday.
I
I'm
am
glad
actually.
you're already on the holiday.
Yes, sir.
How is it going?
It's boring, but I'll manage.
Oh, yeah, oh yeah, nah. Good to hear. Good to hear. Good to hear. Hey, I was like, no, man, I will just talk alone if maybe there's no one who will attend the lesson. I was like, no, I'll just record myself talking alone and just post on the YouTube there. Hi, Oneide, how are you doing?
No, good. How are you, sir?
I'm good, thanks to Uh, I think let me just start sharing the screen. Oh, I'm now sharing. Can you guys see my screen that side? Because I started sharing.
Yes, sir.
Okay, thank you for the feedback. Let me just go to the business
Yes,
of today.
sir.
Okay, thank you for the feedback. So I've got these questions I want us to look at. Starting from this question. This question. Let me just confirm. I think it's only two people who joined today's lesson. Okay, it's fine. Is my zooming okay, or should I zoom a little bit in or out?
It's okay on my side, so.
It's okay, sir.
Oh, okay. Thank you guys for the feedback. So we're just going to do this Western Cape question paper for 2018, question 9. Then we are given that statement of that diagram. They are saying ABC is a semicircle, okay, with the center O. So the center of this semicircle is O. Then AB is reduced to K, okay, such that KCS is a tangent to this circle at point C. So, SO is perpendicular to AB and KCB is equal to 25 degrees. So, okay, my technique, as usual, DRCPT. Okay, yes, there exists a diameter is this one. Therefore, this implies that this angle is 90 degrees. We are done with that. Then the radius, we've got this radius here, this one, and they are equal radii. This implies that this angle will be equal to that angle. We are done with the radius, or not yet. We also have this radius here and that one. They are equal. This implies that this angle will be equal to that angle. Okay, we are done. Then the cyclic quad. Oh man, not no, we don't. Unless you guys maybe see something, then you can just shout it out. And then parallel lines, we don't. And the tangent, okay, they said there exists some tangent. Therefore, this angle between the tangent and the chord will be equal to the interior angle opposite that chord. So it's equal to this, and that angle there will be equal to this angle. Okay, we are done with our analysis. I think we answered every question that we are required to calculate. Now let's just dive into the problem. 9.1, give a reason why CAB is equal to 25. Okay, CAB is this one here. CAB. Okay, we already noted that using DRCPT method. So this angle is between the tangent and the chord. Then in the triangle, it will be equal to the angle that is opposite the chord. This is the chord, and it will be equal to that angle. Therefore, this angle is equal to 25. They want a reason why. Then this is a term called theorem. Does it make sense to you guys?
No, sir.
It doesn't, né?
Yes, sir.
Oh, okay. Let me do this. This is my circle. This is my tangent. This is my triangle. Okay. This triangle is A, B, and C. So, do you agree when I say to you, this angle is equal to that angle, Talcott theorem?
Yes, sir.
Yes, because that angle is between the chord in the circle and the tangent of this circle. And then that angle is equal to the angle in the triangle that is opposite to this chord of focus, which is that one. So, okay, let's go to the question. We have got the angle here. It is between the chord and the tangent here. This is the angle between the chord and the tangent. So in the triangle that is existing in the circle, it will be equal to the angle that is opposite that chord of focus. Therefore, it will be that angle. That's my tan chord theorem. Does it now make sense?
Yes, sir. Thank you.
Are you sure?
Yes, sir.
Okay, thank you. We are saying this is tan chord theorem. Then let me just erase this. Okay, the next question. Give a reason why OCA, this is O, that is C, okay, this one, why that is equal to 25 degrees. So using our DRCPT, when we got to that part of R, which is the radius, we came to this part saying this is the radius, that is radius. So now OA will be equal to OC, reason being radi. Therefore, if this angle is 25, that angle OCA there will also be equal to 25 degrees. Okay, they gave us that. Now they want the reason. Why do I say that is equal to 25? It's because of this is an isosceles triangle. These sides are equal. So you can just say base of an isosceles triangle, or you can say angles opposite equal sides. What am I doing? Angles opposite equal side. Okay, does this one make sense to you guys?
Yes, sir.
Yes, sir.
Oh, okay, thanks for the feedback, guys. Let me just check. It's still only the two of you guys. Okay, let me continue. 9.3. What's happening now to my screen? Okay, I'm sorry for that. And then now with 9.3, write down the reason, or with reason the size of COB. So COB is this one. COB is this angle there. So, okay, I have that angle there at the circumference. I want that angle there at the center. I had that as 25 degrees. Therefore, now this will be 50 degrees. Reason being angle at the center is 2 times the angle at the circumference. Just like that. Does this one make sense to you guys?
Yes.
Yes, sir.
Okay, thank you guys. Now the last part of this question, 9.4. Prove that okay. Where is okay? Prove that okay. Here is okay. Here is okay. Prove that okay is a tangent to the, oh man, I skipped this question. I'm sorry guys, I skipped this question. That is saying prove that CTOB, and you guys didn't shout it out. Prove that CTOB is a cyclic quad. Where is CTOB? CTOB is this one. So how are we going to prove that? Okay, this is what we are going to do. Okay, we are already given that this angle is 90 degrees. Therefore, this angle will be 90 degrees as well, reason being angles on a straight line are supplementary. Okay, then we go to our semicircle because there exists this diameter. Therefore, we said using our DRCPT with that diameter, that implies that this is 90 degrees. Therefore, that implies that this is a cyclic quad. Why? Because when we add these opposite angles, we will get 180 degrees. That is the converse of opposite angles of a cyclic quad are supplementary. Then you are done with that question. Does it make sense to you guys?
Yes, sir.
Okay. I had feedback from one person. Where's the other one? Oh, you are left alone here. Oh, she's still here. Does it make sense to you all, guys?
Yes, sir.
Okay, thank you for the feedback. Now let me move to that last question. Prove that okay, this is okay, is a tangent to the circle passing through SOC. SOC, so that circle is going to pass through SOC. Oh, that's my beautiful circle. Then with this one, in order for us to prove that this is a tangent to that blue circle, we just need to prove the inverse of the tan chord theorem. Oh, this is my angle between the tangent and the chord. We need to prove that this angle is equal to that angle there. So is there any one of you guys who have got some idea of how we can prove this question? Okay, I believe maybe this question is a little bit tricky, maybe to you. Let me just put some light. Okay, we found this angle here. This angle here, we said that is 50 degrees, right? And then we said this angle here is 90 degrees. Angles on a straight line are supplementary. So if this whole angle is 90 and only this portion is 50, okay, we can find this angle here. This angle here, O2, is saying 180 degrees minus that's 90, this 90, okay, minus this 50 here. Okay, this part will give me 90 minus 50, I get 40. Oh, okay, angles on a straight line, then I get 40. Then this angle here is 40 degrees. Okay, then now let me just remove this mess so that maybe my circle, where is it going? Okay, let me just do this. Okay, we found that this angle here is 40. This one is 40, but this one is 50. Okay, this is 50 degrees. Then now, let's try to find that angle S there. How can we find that? Firstly, we know that angle OCS, this one, is 90 degrees using that theorem. Radius is perpendicular to tan because OC is a radius and then CK is a tangent. So rad is perpendicular to tan, that is 90 degrees. Now we want that angle using interior angles of a triangle. So we are going to say that angle S is equal to 180 degrees minus 90 minus 40. So 180 degrees minus 90 minus 40. This will give me 90 degrees minus 40. And then this gives me 50 degrees. Okay, this is 50 degrees. Then now we can come to the conclusion that if there exists some circle here on OCS, this will definitely be a tangent. Why? Because if this is a chord of that circle, and this is a tangent to the circle, this will be angle between the chord and the tangent. And then we now go to the triangle that is existing in that circle. We go to the angle that is opposite that chord of focus. That angle, we found it as 50 degrees. Therefore, that angle there is equal to this angle here. They are both equal to 50. Now we proved that that is a tangent, reason being the converse of tan chord theorem. Does it make sense to you guys?
Yes, sir.
Are you sure?
Yes, sir.
Oh, okay. So let's
Yes,
go
sir.
to the. Okay, thank you for the feedback. I love hearing those feedbacks, guys. Let me just erase. And then let's go to this question. NM. What is NM? I don't know, but whatever. NM 18, 10.2, we are saying in the diagram, the circle with the center F, is drawn. Points A, B, C, D lie on the circle, called AC, AC, and BD intersect at E. Okay, such that EC is equal to ED. Oh, this maybe will help us a lot because now this is an isosceles triangle. Okay, therefore this angle will be equal to that angle, reason being the base of an isosceles triangle or angles opposite equal sides. Okay, we know that. And then K is the midpoint. K is the midpoint of chord BD. Okay, this is BD. BD. According to theorem 1, if this is the midpoint, it means that BD is equal to BK is equal to KD. Therefore, this will be 90 degrees according to theorem 1. Then this will also be 90 degrees. Okay, we know that now. And then let's continue. FKABC. Let angle B be equal to X. Okay. Now, guys, I would love you to work with me. I'm going to ask you some questions to see if you are still following or if you understand Euclidean geometry. So before we can proceed, let me just go highlight some things that can help us. TRCPT, diameter. Is there a diameter, guys, that is existing on this circle?
No, sir.
Okay, there is no diameter. I'm going to skip that. Is there a radius?
Yes, sir.
Yes, sir.
Which one? Which one is the radius in the circle?
FD.
FD. Okay,
AF
then.
and FD.
Oh, okay. Yes, thank you, guys. Therefore, this will be equal to that, reason being radii. And then that implies that this angle is equal to this angle, reason being based off an isosceles triangle or angles opposite equal sides. You guys agree to this part?
Yes, sir.
Okay. Thank you, guys. Then let's go. Okay, we are done with R. Let's go for C. Is there a cyclic quad on this circle? Is there a cyclic quad to this circle?
No, sir.
Okay, you are saying no. What about the other one? Do you agree or not?
No cyclic quads, sir.
Oh, I'm seeing something there. I'm seeing something there. I think you guys maybe you just thrown your eyes and then you didn't see something that is like this. Or you didn't see something that is like this. That is like this. Oh, this is the cyclic quad. And I don't remember well if it was with grade 11s or 12, but I think I emphasized that this part is also the family of the cyclic quad. Therefore, you can consider this as a cyclic quad. Then there exists that bow tie shape there. Do you guys follow that?
Yes, sir.
Yes, sir.
Okay, thank you guys. Therefore, we have got that bow tie shape. This angle will be equal to that angle, and this angle here will be equal to that angle. Reason being angles in the same segment, angles subtended by the same arc, or angles subtended by the same chord. Okay, we are done. Now we are done with that C. Let me just go to P. Are there any parallel lines that exist on this circle, guys?
No, sir.
Oh no, we're just gonna scratch that out. Is there a tangent?
No, sir.
Oh no, thank you for the feedback. Then now let's just quickly dive into the problems. Determine with reasons the size of each of the following in terms of x. Now, what is the size of angle F1? Is there any one of you guys who can tell us the size with some reasons of angle F1? This angle here.
F1 is equals to 2x.
Oh, yes, I 100% agree with you. It's 2x, yes. And then reason behind the statement?
Reason being angle at center is equals to double the angle at circumference.
100% correct. You put your reasoning to get full marks. Okay. And then number C is there, oh, number B. Is there anyone of you guys who can tell us the size of this angle here? This one, angle C. And we noted this somewhere, somehow using the R60 when we were here on C. So we want that angle C there. Anyone who can give it a try? Are you guys maybe still trying to figure that out? Or you got no idea? Are you guys still there?
Yes, sir.
Yes,
Oh,
sir.
okay. Let me just give you guys some hint and then ask you now what is the size of angle C. I think you now see it. You still can't see it? Size of angle C. This one here.
And see it's up, but I'm trying to find the reason for my answer.
Pardon?
I can see it's up, but I'm still trying to find the reason for my answer.
Okay, maybe. Okay, what did you get for that angle C?
I think angle C is equals to 180 minus x.
Okay, you are saying 180 minus x. Then let's just wait for the reason. I'm waiting for your reason now. Are you still trying to find the reason?
Yes, sir.
Oh, okay. Let's just maybe avoid wasting some time. Let me correct that part, but good try though. Thanks, I appreciate it. Now I'm asking you this question. Do you agree when I say this angle here? Why am I erasing that? I have this bow tie shape here. So do you agree when I say to you, okay, that is angle X? This C would also be equal to X. Do you agree to that?
Yes, sir.
Yes, sir.
Oh, I'm glad that you guys agree to that. Then what do you think can be the reason behind that statement? Angles in the same segment. Angles in the same segment. Okay. Angles in the same segment. That bow tie shape exists there. This angle equal to that. This angle equal to that. Okay. Does it make sense to you guys?
Yes,
Yes,
sir.
sir.
Okay. Thank you. Now we go to the last question of this part. Prove with reasons that HFED is a cyclic quadrilateral. Oh, it's 4 marks, but a good mark. So is AFED. AFED is this one. We want to prove that this is a cyclic quad. Is there any one of you guys here for some idea of how we can approach this rider? Anyone of you who maybe can give this problem a try? I assume maybe you guys are still trying to figure that out. Let me maybe just try to give you 1 minute. Then maybe I can continue at 35. we want to prove that this is a cyclic quad. Okay, and this cyclic quad here, we've got these diagonal. Those diagonals, they form something like a bow tie shape. Okay, that's a good hint. We can work on that. Let me put this. Okay. Oh, I think I now gave you guys more than a minute. Are you guys winning that side?
No, sir.
Oh, okay. Let me just dive into it. You guys said this here. You said is 2x, right? Are you guys
Yes, sir.
still there?
Yes,
Okay,
sir.
yes. And then you also agreed that this angle here will be x, that one there, right?
Yes, sir.
Okay.
Yes, sir.
Now, okay, thank you for the feedback. Now, this is very important. They gave us that EC is equal to ED. Then ECD, that triangle, is an isosceles triangle. Now, do you guys agree when I say D3 here is equal to X as well?
Yes, sir.
What's the reason behind that statement?
Converse angles in the same segment.
Sorry?
Converse angles in the same segment.
Angles in the same segment? Which segment, maybe, if I ask? Maybe I didn't see that segment. Oh, okay, maybe you are shy to continue with your statement, but my reason why I say this is equal to x, oh my poor x, this is x. Okay, it's because this line is equal to that line. Therefore, this triangle is an isosceles triangle. Those lines are equal. That is why I say this is the base of an isosceles triangle. Does it make sense to you guys?
Yes, sir.
Okay. I hear feedback from one person.
Yes, sir.
Okay. Thank you, guys. Now I'm going to ask you guys this question here. This one here. If I have got A decrease there for that angle, I have got B decrease there, and then what is the value of X in terms of A and B? I'm now asking you guys this question.
It's AB, sir.
Sorry?
Sir, it's going to be double. It's going to be AB.
So you are saying it's going to be AB.
Yes, sir.
Oh, then I just add this is A plus B. Reason being, exterior angle of a triangle is equal to interior opposite angles. Do you see where maybe you missed this?
Yes, sir.
Okay, thank you. Therefore, X will be equal to A plus B. Okay, now let's go to this triangle. That triangle, we said this is X, this is X. And then now, in this triangle, let's extend BCA like this. And then we have this angle as X and this angle as X. Now we want this angle here. Anyone who can tell us what that angle is? It E? Yeah, it's E. That size of angle E3 there. Is there anyone who can tell us? This is X. This is X here. And we want E3. It's something like this. This
It's
is
equals to 2x.
Oh, yes. This is 2x. Let me erase this. Now, saying this is equal to 2x. Therefore, now I'm having something like, okay, this is my cyclic quad that I'm required to prove, and I have these diagonals of this cyclic quad. And then those diagonals, they form something like a bow tie shape. Now we've shown that this is 2x, and earlier on we found that this is 2x. Therefore, this is a cyclic quad, reason being the converse of angles in the same segment. Therefore, AFED is a cyclic quad. Does it make sense to you all, guys?
Yes, sir.
Are you sure?
Yes, sir.
Okay, thank you. Then just erase. We go to the last question of this part. Now we are required to prove with reasons that F3 is equal to, is it F3? Oh, F3 up there at the center is equal to X. So what can we do now? Okay, we now know that we can just say A, F, E, C is a cyclic quad. Your reasoning being proven in 10.2.2. Okay, that's your first statement and the reason. Now we know that this is a cyclic quad. We know that this is a cyclic quad. There is something there, line extended there. Then there's this theory. If this is a cyclic quad, this is equal to that, reason being exterior angle of a cyclic quad is equal to interior opposite angle. Do you guys agree to this theorem?
Yes, sir.
Yes, sir.
Okay, thank you, guys. Therefore, we can just try to find that angle, and then that will be equal to this angle. How are we going to find that angle? Okay, we had that angle as 2x, and this side is equal to this side. Okay, this angle will be equal to that angle. Therefore, if I let this angle be A, that angle will be A as well. Okay, now I want to make A subject of the formula in terms of X. I want to find A in terms of X. I can just say, okay, angle A plus 2x is equal to 180 degrees. Angles in a triangle are supplementary. Therefore, 2A is equal to 180 degrees minus 2x. Therefore, A will be equal to 90 minus x. Okay, therefore, let me remove this mess again. And then it says this is a cyclic quad. And then I had my A here. Now this angle is 90 minus x. Okay, since AFED is a cyclic quad, this angle here will also be equal to 90 degrees minus x, reason being exterior angle of a cyclic quad is equal to interior opposite angle. Does this make sense to you guys?
Yes.
Oh, okay. I hear feedback from one person. Does it make sense to everyone, guys?
Yes, sir.
Oh, okay. Thank you. Let me just erase this. Now, Oh, let me also erase this actually quad here. It causes some mess. And then that angle E1 is 90 minus X. Okay. We were also given that K is the midpoint of BD. That implies that BK is equal to KD. Now, if that's the case, according to theorem 1, this is 90 degrees. This will also be 90 degrees according to theorem 1. Okay, that is 90 degrees, reason being angles on a straight line. Then we want F3, okay? We want F3. Now that is the triangle FKE. I'm just going to say angle F3 plus that angle FKE plus angle E1 is equal to 180 degrees. Okay, what is F3? Is the one that we are looking for. And then FKE is 90 degrees plus angle E1. Angle E1 there is 90 degrees minus X is equal to 180 degrees. Then let me do this. Then F3 there is a plus 180 degrees minus X is equal to 180 degrees. Then F3 will be equal to 180. I'm transposing this to the other side. It will be negative. Therefore, they will cancel out. I transpose this negative X to that side, and then it will give me X. Then now I proved that angle F3 is equal to X. Does this one make sense to you guys?
Yes, sir.
Are you sure?
Yes, sir.
Oh, okay, guys. Then what I'm going to do, guys, I will just send something for you to do at home. I will send this question of one, and this one, and this one. Are you guys still checking on that channel that we are posting something for you guys to read at home?
Yes, sir.
Yes, sir.
Okay. Okay, guys. So please do check there after 9. After 9 o'clock, I will post something for you guys to read at home. Then next week or next time we meet, we'll just do some correction. Then we will be done with Euclidean geometry afterwards. Otherwise, thank you for being with me, guys, in today's session. I appreciate it.
Bye,
You guys
Welcome,
have a
sir.
good. Oh, cheers, guys. You guys must have a good night. I'm now logging out of the lesson.